Okay, so this is interesting. This week we're diving into the world of programming languages, and specifically all the buzz around Rust. Got a question for you. Is Rust really the future of software? What's the deal here? You sent over some articles and Google's experience with it, comparisons to other languages, even some White House chatter.
Yeah. It's definitely got people talking, and for good reason. I think what's fascinating to me is that this goes way beyond just, like tech circles. This is about, national security even, and how we build a digital world that we can rely on.
That's what I find so intriguing about this. It's not often that you see programming languages, causing this kind of stir outside of developer forums.
Yeah.
Why is everyone suddenly so hyped about Rust when we're talking about something as serious as keeping our data safe?
Well, think about it this way. Imagine software, right, that's built on foundations, but the foundations have cracks in them.
Cracks. Okay, now you got to paint a picture for me here. What are we talking about?
Yeah, so these cracks are vulnerabilities, right? Okay. Flaws at the code level that hackers can exploit to get in, to steal data, all sorts of nasty stuff. Think of it like a leaky pipe in your house, right? A small leak might seem minor, but over time it can cause some pretty major structural damage. And these vulnerabilities, they're not just hypothetical. A report from the Office of the National Cyber Director actually found that a whopping 70% of severe security bugs are actually memory safety issues.
70%. That's a huge red flag.
Exactly. And this is where Rust comes in. Rust is designed from the ground up to be what we call memory safe, meaning it's designed to prevent these vulnerabilities in the first place.
So instead of patching leaks in a rickety old house, we're talking about building a fortress from the get-go.
Precisely. And the impact is huge. One of the articles you shared talks about how Google used Rust to rewrite parts of Android, and they saw a 52% drop in memory safety vulnerabilities in just a few years. That's massive.
52%. That's incredible. And Google's Android, that powers a ton of devices. So that kind of improvement, that's not just some tech industry win. That affects everyone listening to this right now, everyone who uses a smartphone.
Yeah.
I'm guessing this success is part of what got everyone else so excited about it.
Oh, it's definitely a driving force. Google's results have been, they've been a game changer. Other companies are definitely taking notice. In fact, even the White House is getting involved. They released a report advocating for memory-safe languages, especially Rust, to be used in building and maintaining a critical software infrastructure.
Wow, this White House is weighing in on programming languages now. That's, I guess that really emphasizes just how crucial this whole shift towards memory safety really is. It's more than just, making things harder for hackers, though, right?
Yeah.
I think it was the Analytics Insight article. One of the articles you said mentioned some other benefits of Rust, like how fast it runs compared to other languages.
You're right. Security is a major, major plus, but Rust offers more than just, fewer bugs. It's known for being incredibly efficient, especially compared to a language like Python, which is used absolutely everywhere. We're talking near native performance, meaning it can go, toe-to-toe with something like C++ in terms of speed, but it's got that added layer of memory safety built in.
So it sounds like we're talking about a programming language that's not just way more secure, but could be potentially faster too. That's a pretty powerful combination. But let's talk about the real world for a sec. How realistic is it to expect, every company, every developer to just jump on the Rust bandwagon? Switching programming languages, I imagine that's not exactly like switching, phone brands, is it?
You're right. It's a big ask. Transitioning to any new technology has its hurdles, right? For developers, there's a learning curve. Rewriting existing code bases in Rust, it can be a complex process. It's kind of like trying to, translate a novel into a completely different language, but still trying to preserve the original meaning.
Oh, yeah. I can imagine. Even learning a new, a new spoken language can be a trip, right? You're bound to get some funny looks until you get a handle on it.
Exactly. And plus, there's also the question of, finding skilled Rust developers. And although the community is growing super fast, it's still a relatively new language, compared to some others out there. Finding experienced programmers who are fluent in Rust, that takes time.
Yeah. It's a little of a chicken and egg situation then, huh? You need people to use the language to get good at it. But companies, they also need experienced developers to feel comfortable enough to make the switch in the first place.
That's always the challenge with any new technology, right? But the momentum behind Rust right now it's undeniable. And remember that Info Security Magazine article that you sent over? The one analyzing the Open Source Security Foundation's list of critical projects?
Right, the one highlighting all those projects that underpin so much of our digital infrastructure. Yeah, what about it?
Well, their analysis actually showed that more than half of those projects, more than half, are still written in memory-unsafe languages. And we're not talking about, some small-time projects here. These are the foundations of our online world, right? So the potential for vulnerabilities, that's a huge concern.
That is a sobering thought for sure.
Yeah.
So we're relying on these systems that at their core are vulnerable to these memory safety issues. So, are we headed towards a future then where everything is written in Rust? Is that the solution?
I think it's too early to say if Rust will be the language of the future, right? But I think the bigger picture here, the thing to really pay attention to is this larger shift toward memory safety itself, whether it's Rust or, another language that comes along that addresses these same issues, this focus on security, on building security from the ground up that's here to stay.
Yeah, that makes sense. The focus needs to be on building more secure foundations, I guess, regardless of what the specific tools are, right? But okay, so this whole shift towards memory-safe languages, if it's as big of a deal as it seems, what kind of impact could that have on, on our everyday, digital lives, for the average person?
Well, that's the exciting part, right? Imagine a world where software vulnerabilities, they're just significantly less common, way less common than they are now. We're talking fewer crashes, fewer security breaches, fewer of those, those dreaded software updates that always seem to pop up at the worst possible time.
Oh, fewer software updates? That alone would be a huge win in my book.
Right.
But it's got to be more than just convenience though, right?
Oh, absolutely. This is about trust. Imagine, right, interacting with your online banking, healthcare systems, even just sending emails, right? But with a much greater sense of confidence, knowing that the systems that you're relying on, they're fundamentally more secure because these issues have been addressed at the code level.
Yeah, it's like the difference between driving a car that's, well-maintained, regularly serviced versus one that's, kind of held together with duct tape and hope, right? You hit a bump in the road and
exactly.
You can go either way.
And this shift toward memory safety, that's what it's all about, right? It's about creating this digital world that's not only more secure, but also just more reliable, more innovative, and ultimately more user-friendly for everyone.
Okay, so to bring it all back, I guess, we've talked about this, this pretty widespread issue of memory safety vulnerabilities, how Rust is kind of emerging as a potential solution with, all of its security and performance advantages that we've been talking about. We also talked about, the challenges of transitioning to any new technology and the need for skilled developers, which is always a challenge. But it seems like the main takeaway here is that this shift towards memory-safe programming, it's bigger than just Rust, right? It's not even about one language. It's like this fundamental shift in how we need to be thinking about, building the software that powers, pretty much everything these days.
You nailed it. And honestly, it's an exciting time to be involved in software development at all, right? Because these challenges that we're talking about, they're pushing us towards a more resilient, a more trustworthy kind of digital future.
Yeah. Yep. No, I'm right there with you. Well, that's about all the time we have for this week's deep dive. But before we go, I always like to leave our listeners with a little something to ponder. So if this vision of, a more secure, a more reliable digital world, if all that actually becomes a reality, what kind of changes, big or small, might we see in our everyday lives? How would we interact with technology differently? What new possibilities might it unlock? Food for thought. Thanks for joining us. We'll catch you in the next episode.